Have you ever imagined that throwing away glass bottles is actually a big mistake? Most people instinctively toss them in the trash without a second thought. What almost no one realizes is that this ordinary material can hide a real gold mine, full of profitable possibilities and surprisingly smart reuse opportunities. The first step is to carefully separate the glass bottles into a sturdy, appropriate container, making sure everything is well organized for the process. When handling this type of material, safety must be your top priority. It's essential to wear protective safety glasses to shield your eyes and heavy-duty gloves to protect your hands from cuts, ensuring a safe and efficient workflow. To carry out this experiment, I'm going to use a heavy-duty plastic bag and carefully pour the glass shards inside, making sure everything stays secure and contained. As you may have noticed, the first fragments come from green bottles, which directly influence the final outcome. That's why I'll also add blue bottles to the bag, creating a strategic mix. In the end, you'll discover the truly surprising result of this glass combination. After placing the glass shards and the whole bottles inside the heavy-duty bag, I'll use a hammer to carefully break them apart. I'll apply light, controlled taps to keep everything safe and contained, gradually crushing the material into smaller, more uniform pieces that are perfect for the next step of the experiment. And go ahead and jump into the comments. I'd really love to know where you're watching from. Drop your city and country below. If you prefer, tell me what you do for a living. It would be awesome to get to know the amazing people who are part of this community. After that, simply sort through the pieces and discard the glass shards that won't be useful for the experiment, especially the neck and the bottom of the bottles, where the curves are more pronounced. Those areas don't provide the same level of usability. The remaining flatter, more uniform pieces will be the perfect material to serve as the ideal test subjects for the experiment. In addition to the glass shards, we'll also need white cement to give the mixture strength and structure. Here I have two 5-kilogram bags totaling 10 kilograms of cement, an ideal amount to ensure solid coverage and good results for this experiment. I'll pour all of it into a large, sturdy container, preferably a big mixing tub, so there's plenty of room to blend everything properly and avoid any mess during the process. Once the white cement is in the container, it's time to add the glass shards we selected earlier. Pour all of them in at once, making sure they spread evenly over the cement. Then start mixing slowly and thoroughly, working the shards in until they're evenly distributed throughout the mixture. At this stage, there's no need for any special tools. Everything can be done by hand, as long as you stay careful and in control. After thoroughly mixing the white cement and the glass shards, the next step is to prepare a homemade plasticizing additive to improve the workability of the mix. For this, I'll use white PVA glue and clean water. I'll pour in a generous amount of glue, about 100 grams, and fully dissolve it in the water, stirring until I get a smooth, consistent solution. This mixture will then be added to the main batch to enhance bonding and flexibility. This PVA glue-based plasticizing additive is an old, time-tested technique often used to improve the performance of cement mixtures. Its main purpose is to enhance workability, providing better bonding, improved cohesion between materials, and contributing to the overall strength of the cement once it cures. After preparing the solution and pouring it into the mix, the key is gradual application. Add the liquid little by little, mixing thoroughly before adding more. This control is essential to prevent excess water, which could weaken the strength and consistency of the batch. The ideal point is when the mixture becomes smooth, firm, and easy to shape, without being too runny. Notice how simple and accessible this entire process is. There's no need for expensive tools or advanced technical skills, just attention to detail, patience, and care at every stage of the experiment. After fully preparing the cement mixture, it's time to move on to another key step in the process, getting the surface ready to receive the material. Right here in front of me, I have a concrete mold designed specifically for making a concrete sink. Before pouring the mix, we need to prep the inside of the mold. For this, I'll be using used motor oil as a release agent to help with easy removal after curing. The application is simple. Just use a brush to spread a thin, even coat, making sure it doesn't drip or pool. That said, you can absolutely go with the conventional method and use an eco-friendly release agent or whatever suitable product is easiest for you to access. With everything properly set up, it's time to pour the white cement mixture into the mold. The process is simple, but it requires attention to detail. Make sure the mold is sitting on a completely level and stable surface to ensure a smooth, even finish. Then carefully pour the concrete in, spreading the mixture gradually and evenly until it reaches the top edge of the mold. To remove the air bubbles from the mixture, I'm going to use an improvised tool, an electric massager. The idea is simple and effective. Instead of applying vibration directly to the concrete, I'll place the device against the outside of the mold, allowing the vibration to travel through the entire structure. This movement helps release any trapped air bubbles inside the mix, letting them rise to the surface. The result is a denser, more uniform concrete with a much more professional-looking finish. After that, just allow at least 24 hours for the cement to fully cure, ensuring proper strength before moving on to the next steps of the process. After the 24-hour curing period, it's time to remove the cement piece from the mold. This step is simple, but it should be done carefully to protect the details and the finish. Place the mold upside down on a flat, level surface. Then gently lift and separate it without using excessive force. With slow, controlled movements, the piece should release naturally, just like I'm demonstrating here, ensuring a clean, solid. To achieve a truly professional finish, I'll start by sanding the entire surface of the piece. First, I'll use 60 grit sandpaper, which is more aggressive, to grind down the top layer until the glass shards begin to show. These exposed fragments are what create the decorative and eye-catching effect in the final piece. The sanding will be done dry, so it's very important to wear a dust mask to avoid breathing in fine particles. After completing this initial step, I recommend switching to a finer grit, such as 150 or 220, to smooth and refine the surface, giving it a cleaner, more polished, and visually appealing finish. You can already start to see the details coming through on the surface, which means the goal is being achieved. Using the 150 grit sandpaper significantly improves the overall finish, making the piece more uniform while further highlighting the glass fragments. Next, it's best to move on to a finer grit, such as 320 or 400, to refine the texture even more and remove any small imperfections. This final sanding stage creates a smoother feel and a more polished, high-end look. At this point, the piece will be properly prepared to receive any touch-ups and the next steps in the finishing process. Now we're getting to the step that truly makes all the difference in the final result. Don't click away, because what comes next will reveal the key detail that completely transforms this piece. Now it's time to apply a traditional and highly effective technique to further strengthen the piece. I'll carefully place it inside a suitable container and add water until it's completely submerged. This process helps enhance the curing of the cement, increasing its strength and durability. The piece will remain underwater for another 24 hours, ensuring a stronger, more stable, and long-lasting final result. After remaining submerged in water for 24 hours, it's time to remove the piece and let it dry naturally. Place it in a well-ventilated area protected from rain splashes or excess moisture. Allow it to sit for another 24 hours to ensure it dries completely and evenly. After 24 hours of proper drying, the piece is fully cured, strong, and ready for the final finishing touches. Now it's time to apply a key product to ensure superior protection and finishing, the acrylic resin. I'll carefully measure approximately 100 milliliters and pour it into a completely clean, dry container, preventing any contamination that could compromise adhesion, uniformity, and the final performance of the coating. Applying this product is simple and efficient. Using an appropriate brush, spread the acrylic resin evenly across the entire surface, ensuring complete coverage. This step is essential to provide waterproofing and structural protection for the piece. However, the process doesn't end here. The next procedure is the main one, so stay tuned. The acrylic resin must dry for a minimum of 24 hours, which is the ideal time for proper curing and maximum performance. After 24 hours of complete drying, the acrylic resin is fully cured and the surface is properly prepared. Now, it's the perfect time to apply a distinctive, sophisticated, and visually refined finish. The final product of this experiment will be the application of epoxy resin, designed to provide a high level of strength, a glass-like finish, and outstanding durability. Here, in two separate containers, are the system components. Component A, which is the base resin, and Component B, the hardener responsible for triggering the chemical curing reaction. To ensure the exact ratio and prevent issues such as incomplete curing, excessive rigidity, or surface tackiness, I will use a precision scale. The recommended ratio for this specific type of epoxy resin is 2:1, meaning 50% hardener in relation to the measured amount of resin. In this procedure, I will measure out exactly 90 grams of epoxy resin and then 45 grams of hardener, ensuring a technically accurate mixture and optimal structural performance. After adding components A and B into the same container, begin mixing with smooth, steady movements, avoiding the incorporation of air bubbles. Stir carefully, scraping the sides and bottom of the container for approximately 3 to 5 minutes to ensure complete blending and a uniform chemical reaction. Next, proceed with the application immediately after mixing, since the resin has a limited working time. At this stage, it's essential to work quickly and precisely to prevent the curing process from starting in the container. I'll use a suitable brush to spread the material evenly, carefully controlling the thickness. The goal is to apply just one continuous, well-leveled coat, ensuring a smooth, uniform finish without excess buildup. If you're not subscribed yet, now's the perfect time to join our community. Go ahead and subscribe to the channel, turn on notifications, and stay up to date with all the upcoming experiments, tests, and surprising discoveries coming your way. The application of epoxy resin can vary significantly depending on the type of product used, especially regarding the mixing ratio, working time, and curing period. Each formulation has specific technical characteristics that must be strictly followed. In the case of this resin applied to the piece, the estimated curing time is approximately 24 hours, after which it will be ready for use. However, the safest approach is always to follow the manufacturer's instructions. In addition, be sure to wear gloves and safety glasses to ensure maximum protection throughout the entire process. After 24 hours of full curing, the resin reaches its optimal hardening stage, ensuring maximum strength and a superior finish. At this point, the piece is ready to be installed in its final position with complete confidence. It's essential to keep it protected from dust, excessive moisture, and strong air drafts during the curing process. This helps maintain proper leveling, prevents surface imperfections, and guarantees a smooth, deep, professional-grade shine, just like the results shown here. And just like that, you've learned a complete step-by-step process to transform glass shards that would normally be thrown away into a sophisticated, exclusive, high-value piece. What was once considered useless waste can now become a refined, modern-looking product with strong commercial potential and real market appeal. In addition to promoting material reuse, this technique allows you to create unique, customized pieces that are practically impossible to find in traditional stores. Each composition can feature a different design, further increasing its perceived value and exclusivity. With dedication, attention to detail in the finishing process, and strong presentation, this type of work can even generate extra income, all from the comfort of your own home. Never throw old CDs in the trash. They hide an incredible secret that very few people know about, and it could be worth a lot of money. In today's video, you'll discover a creative, simple, and extremely satisfying idea using old CDs that are probably just sitting around your home. Not only will you be reusing materials, but you can also turn something worthless into something surprising. Stay until the end and see how this technique can open up new opportunities and even generate extra income in a practical and accessible way. To start the project, you'll only need a sturdy pair of scissors. The first step is to cut the CD into small fragments, almost like shiny gravel. The more precise and clean your cuts are, the better the final result will be. Focus on making triangle-shaped pieces as they create a more dynamic and visually appealing effect. Then, add some random cuts, squares, rectangles, and other shapes. The greater the variety and quantity of pieces, the more surprising, detailed, and professional your final project will look. And go ahead and jump into the comments. I'd really love to know where you're watching from. Drop your city and country below. If you prefer, tell me what you do for a living. It would be awesome to get to know the amazing people who are part of this community. In this project, I'm using 16 old CDs, repurposing each one strategically to achieve a more efficient and visually impressive final result. After cutting all the CDs, I place the fragments into an organized container. Next, I prepare the base structure of the experiment, defining support, alignment, and fixation to achieve a precise and functional result. The next step is sanding the wooden surface to remove splinters and imperfections, preparing the base for the next stages of the project. I use 220 grit sandpaper, suitable for a fine finish, ensuring even leveling without damaging the material. The process is applied across the entire top surface and along the edges, using steady, controlled motions to avoid marks or excessive wear. After completing the sanding, I remove all dust with a slightly damp cloth, leaving the surface clean, smooth, and ready for the next procedures, ensuring better adhesion and overall quality in the final result. After sanding, I move on to applying wood filler, essential for correcting micro imperfections and fully leveling the surface. I chose a round wooden piece to achieve a more precise, uniform, and visually balanced finish, enhancing the overall quality of the project. The first coat is applied using a silicone spatula, spreading a thin, continuous layer just enough to cover the entire surface without excess. The process also includes the edges, ensuring complete consistency across the structure. I maintain controlled pressure during application to prevent buildup and unwanted marks. This step creates a more even base, making the next finishing stages easier and ensuring a cleaner, more professional final result. After applying the first coat, allow a minimum drying time of 3 hours to ensure proper curing of the filler. This period may vary depending on temperature and humidity. Always follow the manufacturer's instructions to guarantee proper performance and high-quality results in the next steps. After 24 hours, the piece is fully dry and ready for the second coat. I repeat the same process using a silicone spatula to apply a thin, even layer only over the imperfections, ensuring precise leveling without material buildup. Controlled application prevents marks and improves the final finish. This step enhances surface uniformity, preparing the base for the next stages with better structural and visual quality. After application, allow a minimum drying time of 6 hours before starting any further process. After 6 hours, the piece is properly dry and ready for finishing. I begin sanding with 220 grit sandpaper to correct imperfections from the applied filler and achieve an even surface. I use light, consistent strokes, avoiding excess pressure to preserve the finish. The process is manual, precise, and efficient, requiring no additional tools. I pay close attention to edges and critical areas to maintain full uniformity. The goal is to achieve a smooth, continuous, and stable surface ready for the next steps, ensuring better adhesion, a refined finish, and high-quality final results. After completing the initial sanding, use a finer grit to refine the surface. I use 320 grit and can move up to 400 for a superior, more uniform finish. Apply controlled strokes to remove residual marks. Wear a protective mask as the fine dust requires proper safety throughout the process. Next, wipe the piece with a clean, dry cloth, removing all dust residue and leaving the surface fully prepared for the final finish. As a skilled craftsman, I will perform an additional procedure on this piece, focused on the final finishes, ensuring precision, refinement, and a high-standard, visually consistent result. What I'm about to apply is right here in front of me, synthetic enamel, ready to use. I'll separate an appropriate amount into a clean container, ensuring control and preventing contamination during application. The piece is already positioned, waiting for the final finishing stage. The black color is not a random choice. It enhances contrast, highlights details, and delivers a technical, sophisticated look. The final result will reflect precision, uniformity, and long-lasting durability of the applied coating. Paint application requires control, not force. Use a foam roller or a low nap roller to ensure even distribution and prevent streaks. Load the roller evenly, removing excess before making contact with the surface. Apply using continuous strokes, crossing passes to level the coat and eliminate imperfections. At this stage, apply only one coat, but ensure full coverage with a well-balanced thickness, avoiding buildup that could affect the finish and curing time. Respect a minimum drying interval of 12 hours under normal conditions, taking into account controlled temperature and humidity. Colder or more humid environments may extend this time. After drying, the piece will have initial strength suitable for light use. Always check the manufacturer's specifications, as the paint formulation and regional conditions directly impact the final performance and durability of the applied coating. After 12 hours of drying time for the synthetic enamel, I begin the next step of the process. Now, I'll show how to apply the pre-cut CDs, explaining the correct positioning, proper fixation, and the necessary precautions to achieve a precise, well-executed result. The application of the cut CDs is done using superglue, ensuring fast adhesion and precise control throughout the process. The starting point should be the center of the piece. Since it has a round shape, this reference ensures alignment, symmetry, and balanced distribution of the elements. Begin by using the larger fragments, triangular and rectangular, as they form the structural base of the mosaic. Position each piece accurately, maintaining uniform spacing between them to create a clean and well-defined pattern. Progress outward from the center toward the edges, adjusting fit and orientation as needed. Avoid glue buildup to preserve a clean finish. The goal is to create a visually balanced mosaic with strong organization, contrast, and a high level of technical finish. As you approach the edges, trim the fragments as needed to ensure a precise fit and continuity of the pattern. This stage requires maximum care, steady control, and constant visual judgment. Work with attention to detail, adjusting each piece patiently, avoiding haste and imperfections that could compromise alignment and the final finish of the mosaic. The mosaic is finished. Now I'll prepare the next product that will transform the result, elevating the finish and creating an impressive effect. The product prepared for this stage is epoxy resin. I have component A, resin, and component B, hardener, which must be combined with maximum precision. To ensure accuracy, I use a precision scale following the exact 2-to-1 ratio where the hardener equals 50% of the resin amount. Correct measurement is essential to achieve proper curing, strength, and clarity in the final result. After measuring, I mix thoroughly to achieve a uniform blend while avoiding excess air bubbles. This first layer of epoxy is responsible for sealing the entire surface, bonding the CD fragments and creating a stable, even base for the next finishing steps. For mixing, work in a controlled, even manner at a slow pace. Continuously scrape the bottom and sides of the container to ensure full integration of the components. Keep the process between 3 and 5 minutes, avoiding excessive agitation to prevent bubbles and preserve final clarity. As mentioned earlier, this first resin application is solely for sealing. The ideal interval for the second coat is about 3 hours when the surface is still tacky and not fully cured. At this stage, use latex gloves for safe handling and better control. Apply with smooth, controlled motions, gently working the resin across the entire surface to ensure it penetrates between the CD fragments. Work piece by piece, ensuring even coverage and eliminating gaps. This step is essential to consolidate the base, improve adhesion, and properly prepare the surface for the final finish. To remove bubbles, use a heat gun on the lowest setting. Keep it about 6 inches away from the surface, applying heat quickly and in a controlled manner. Avoid concentrating heat in one spot to prevent affecting leveling and the final finish. After 3 hours, with the resin still in the curing phase, I begin preparing the second coat. I weigh the epoxy resin, component A, and the hardener, component B, again, maintaining the exact recommended ratio. At this stage, I use a larger amount of material according to the coverage needed. The mixture is done in a controlled manner for 3 to 5 minutes, ensuring complete homogenization of the components. I scrape the bottom and sides of the container to prevent curing issues. Next, pour the entire resin onto the surface in a steady, controlled flow. Make sure the piece is perfectly level, clean, and free of dust. Also ensure proper ventilation for a smooth, defect-free finish. If you're not subscribed yet, this is the perfect time to join our community. Subscribe to the channel now, turn on notifications, and stay close to all the upcoming experiments, tests, and surprising discoveries coming your way. After pouring the resin, use the heat gun again on a low setting, keeping a proper distance and constant movement. Direct the heat to help level the surface and remove bubbles, especially in areas where the resin hasn't fully spread yet. Avoid concentrating heat in one spot to prevent compromising the finish. Gently adjust the distribution as needed, ensuring a uniform surface. The recommended curing time is at least 24 hours, depending on environmental conditions to achieve maximum strength and clarity. After 24 hours of curing, the resin is fully dry, revealing a high-gloss surface with a refined finish. The piece is complete, with a sophisticated look and ready for use. The result stands out not only for its appearance, but also for its function, making it a true standout piece. Here is the final result of the entire process. executed with precision and patience at every stage. The project resulted in a unique coffee table, built from materials that would have been discarded. Every detail reflects transformation, technique, and purpose, creating a one-of-a-kind piece with strong visual impact and a refined finish that impresses anyone who sees it. If you liked it, share it with friends and family. Help spread creative ideas and inspire more people to turn simple materials into amazing projects.